So we'll go directly to the software. So when you click on the new file, then only you will understand if your registration is completely done. As you can see in this menu bar, we have got all the tabs according to our process, but we'll be I'll be performing over here the easiest process. So let me tell you what all things we are going to start with. We are going to do the properties at the first, then we'll create floor plan, then we'll generate some braces, wind braces, we'll generate stories, then we'll create truss, then we'll provide boundary conditions, and then after that we'll go to the loads, as you can see, and we'll do some analysis, perform analysis, and then we'll see the results, and after results we'll be showing the design. So let us go to the creating of properties. Material properties, add. So we have got a huge database. So according to IS, let us take FE 440. Okay. Then sections, over here directly we can create sections, add. So let us create some columns, floor girders, using I section. So first let's create some exterior columns. So as you can see over here, we have got huge database of using IS code. So IS 1161 is used. IS ME 400, that's what we'll take. Clicking on apply will let you create another section property. Let's create some roof level girders. Let's keep it as the same property. Then interior columns. Let's keep it as IS MB 500. Then we'll create some floor girders. Using IS MB 250. Now we'll create the sections for roof truss. So we need some double angle section. So this lets these be the top and bottom chords. So now for creating the double angle section, we have to click on the user. Use the IS 1161. So let's take 110 by 12. Apply. Then we'll go ahead for roof bracing. That is going to be single angle section. So go ahead on database. Okay, so here we are creating angle section for roof bracing. Let us take it as 100 by 100 by 10. We'll create some vertical and diagonal double angle sections. So again, click on the user as 1161 already selected. Now these be at 100 by 100 by 8. And we'll create wind braces. Double angle again. This will be 110 by 10. Okay. So now we are done with creating some sections. Let us go ahead for creating using node and elements. So basically, let us start with creating a node. So apply. These are some selection tools which we'll be using throughout. So first is a select single, in with which you can just by clicking select or by dragging you can make a box. Okay, so now we'll translate this at 10 meters in the X direction. Now let me tell you about the user interface. We have got horizontal plane as XY and vertical as Z direction. So that's why we have dx, dy and dz. So the dx will translate this element twice. Apply. Okay. Now we'll select all and we'll again translate these in the y direction. Let's take it as 8 meters, make it as 4 times. Apply. Okay. The previous ones did not happen. Let us again create it 10 twice. Apply. Okay. So now we are going to create some column members using the extrude option. So let us make different like exterior columns different. So let's select the exterior nodes. Okay, over here itself in this command we can choose our material and we can choose the section properties during the creation only. So now in the dx, dy, dz equal distance, let us take it as 4 meters height. Apply. So you can see over here that our exterior columns have been created. Now just for display, I'll just change the colors for a better view. Now let's create the interior columns as well. Okay, now the interior columns are done. We'll create some floor girders using create element. So I choose the floor girders property, section property, and click on the nodal connectivity. So over here, as we can see, we are intersecting any node and element coming in between. So let's start from one end to the other end directly. So as you can see, the beams are automatically divided. Now we'll see how we can translate the recently created element using this selection by recently created elements. So now we have directly selected, and now we're going to use the translate option, which has got the two modes, that is copy and move. So we're going to copy using this. Now selecting a distance, what if you do not know the exact distance? So you can simply click on one node to the other node and understand what the distance is. Twice, intersect node and elements, and apply. Okay, so similarly, let us create some more floor beams using the translate command. I'm going to translate this 4 times. Apply. Sorry, you have to select this and then say apply. Okay, now I'll divide this beam into 4 equal parts. So as you can see over here, 1, 2, and 3 nodes have been created. Now I'll create the elements, the floor girders again, using this ortho option. This is the 90-degree snapping of the element. So I take from one node and I snap it to this element, and at 90 degrees it has snapped on. It has created a node on that element. So this becomes easier. Okay, now let me show some more of snapping tools for like for making wind braces. Now let's choose wind braces. So let's turn on off the ortho. Yeah, now we are snapping over here, as you can see, in the center of an element, a beam element. So we do not need to select that element and divide it into two and then create the elements. Instead of that, you can just directly click on one node and click on the other center, or it is snapped, so it automatically creates a node. Okay, now let us use the command of mirror. Okay, we have selected these two entities. Now I want to mirror it in the x direction, so I just select the node, or rather the distance. I say apply. Okay, so now I go ahead and translate these entities again at this distance twice. Apply. Similarly, I can create the wind braces over here, and the recently one, and also this, and translate this one again. From here to here and apply. Okay, some more of the floor beams are remaining over here, so let's just create them. Okay, so now we're done with the one floor modeling. Let us now translate it and create another story. So what I do, I say select all, use the translate option, and translate it at 4 meters. That's the height that we have given for the columns, and apply. So now 2 floors have been generated. The next is keeping the trusses on certain columns. So we're going to select only the exterior columns on which the trusses are going to be kept. So using a select single command, I'm creating boxes of selection. So all are selected. Let's use the unselect by window command. and unselect the nodes that we do not want to be okay. Now we'll use the extrude command. Now even though some elements have been selected, the nodes to line elements is the command, so it will only take the nodes that we have selected, not the elements. Okay, exterior column, vertical height of 4 meters, and apply. So you can see over here our exterior columns for the trusses are ready. Now let us go ahead and generate the truss section. Now going in the structure tab, go in the base structures for wizards. Over here you can see beams, columns, arches, frames, trusses, plates, shells, such kind of wizards are available. We'll go for the truss. So as you can see over here in the truss wizard, we have got various types. So let's select the most common triangular one. That there are different types of diagonals that we can use. Increasing the number of panels. Length of one side is 10 meters. The height is 3 meters and it is going to be asymmetric. Going in the edit, we can insert verticals, and now the material properties and the section properties we can directly assign. So basically for top chords, we can see over here in the workstream menu the section properties and the numbers given to them. So now the top and bottom chords are number 5. Then the verticals and diagonals are number 7. Let us go in the insert. Now the insert point, if you don't know exactly, you can just click over here when it turns green. Click on the node on which you want to rest the truss on. And also which point will be resting on which node, on that node will be seen by clicking on the show number. And then I say OK. So as you can see over here, our one truss has been created. Even in the workstream menu, you will see that the truss elements are there, and also the beam and releases have already been applied. I have right clicked and then there are certain options for displaying and undisplaying. Okay, so now we will just select the recently created entity, that is the roof truss, and say activate. So this is going to isolate it from the rest of the structure. So now we're going to create certain more verticals and diagonals in this. So we need to understand that the element type is truss over here. Exterior column, let's take it as the verticals and diagonals. So similarly I'm doing like I had explained before, snapping on to the centers of the other elements. Okay, so let us just select all and translate it in the y direction, 4 meters, and make it as 8, intersecting the nodes and elements, copy node attributes and element attributes, and apply. Okay, now we will activate all. Now we have to create the roof girders. Okay, so let us go in the create elements and create the roof girders. This will be general beam type. Roof level girders. So let us just select from one node to the other node. Similarly, over here. And now we require to translate it. So we can just say the previously or recently created entity, as you can see. And the translate option, the distance from here to here. Now this is going to take some other node, but we have to see only the x direction. So I'm changing the y direction to 0. And this is going to be 1, 2, 3, 4 times. So I'll just say 4 over here and apply. Okay. So we can see the roof girders have been created. Okay. Similarly, I can create the purlins. Now for purlins, we have not created any section property. So instead of going back to the properties and clicking on the section properties and then saying add, what we can do is in this command itself, click on the box over here to directly get into that command. Then say add, we'll say a channel section, say purlins, IS1161, let's take ISMC 100. Okay, so now we'll use the extrude command, that will be better. So we'll select all the nodes on which we need to rest the purlins. Let us not select the last one using unselect by window option. This will be y direction 4 and say apply. Okay, so now our purlins, it will be purlins recently selected, apply. Okay, now our purlins have been created. Now we need to do the roof bracing. So let us isolate Okay, now we need to create one more element, roof level girder at the center. Okay, now we'll create the roof bracings. So for roof bracings, we do not want to intersect the elements. So let us start creating roof bracings. Okay, so we can just simply create from one side and use the translate and mirror commands. Let's take it as a mirror command. Select these entities. This is in Y. So I have selected just the node and apply. Just do not intersect the node and elements. Similarly, I'll just go in the top view and select all these entities. And using the mirror command, this is going to be now in the Y direction. So I choose the center and apply. Similarly, I'll just select these two and use the translate command. This is the distance and I want it to be done in 1, 2, 3, 4, 5, 6 times. So now our roof bracings are also done. So as you can see, our entire modeling has been completed. Now we'll go ahead with the boundary conditions. We'll be defining the supports. This is the first command itself. So let us just select all the nodes. Now this is direction all and rotation all. That means all the X, Y, Z directions are restricted and the moments in the X, Y, Z directions are restricted if we click on them, check on them. Now there is this RW which is for the warping effect. That means we have got 7 DOF, degrees of freedom. Let us apply. Okay. So now boundary also is done. Let us go ahead with the loading. Now we have got static loading and dynamic loading, and rest of the loadings are also available, but in this webinar I'll be showcasing only the static loading, static wind loads and the floor load, as in the element loads. So let us start creating the load cases. Let us first create self weight. The self weight will come under the dead loads. Add. We'll create live load. That shall come under the live loads. And we'll create wind load in X direction. Let's say wind load X. Select the wind load on structure. We'll create in Y direction. Similarly, wind load on structure and also roof wind load. Okay. So now firstly we'll create the self weight. So this is a self weight command. You have to choose the right load case name. Any groups, load groups that you have created, that also. Now over here, this shows in which direction your gravitational force is acting. So in the Z direction, that too in the minus Z direction, and we are providing -1 so that it's absolute value, so it takes 100% of the elements that we have created in the file, the entire self weight, and we click on add, close. So our self weight has been assigned. Next we'll go ahead and create some element loads. So we'll create live load. Let us just select all these floors on which we want to create the element loads, isolate them. Rather, let's take the top view. Now let's keep the outer girders having the load of 11.5 kilonewton per meter, and the inner girders will have load of -5.6 kilonewton per meter. So I'll just quickly select the outer girders. Okay. So this is uniform loads, concentrated loads, moments, trapezoidal loads. All these options are available. Now it is very important, because this is a finite element based software solution, that we provide the minus sign for the software to understand that it is in the negative Z direction. As you can see over here, the global Z direction. So 11.5. Apply. Okay. The error has come over here. As you can see that no beam elements have been selected. So I think while creating we had not seen if the elements were beams or trusses. So what I can do over here is simply just the selected elements, I can go in the node element and say change parameters. Let me just open all of them. Okay, so selecting all, I'll change the element type from truss to general beam and apply. So these are just warnings. So before applying the loads and the boundary conditions, the element type should be changed. Otherwise, if the element type is changed after loading, the loads will be cancelled. So let us go now back to the floors. And create the element load minus 11.5. Select the outer girders. Okay, so you can see over here the UDL has been applied. Similarly, for inner girders, let's take 5.6 kilonewton per meter. The units are always there. Apply. So even I think these will be outer girders also. Okay, so this is done. The next part, I'll activate all. Now next is we're going to apply some roof loads, that is wind load. So I'll just quickly show this. Using this select by polygon, I can select my top chord and activate. Now I can just select, yeah, this is a beam element. I've just double clicked to just check. Now I'm going to apply. Let us also remove this. This is like you can inactivate it. So I require only the purlins, so we can just inactivate all of them. And rather I would select only the top chords by going to the workstream menu and just double clicking on these, and I'll just activate them again. So select all elements, element loads. Now this is going to be roof wind load. Let's take it as 5.4. This will be in the local Z direction and apply. So as you can see over here, the wind loads on the roof truss has been applied in the local Z direction. Now let us go ahead and apply the other wind loads on the columns. So let us just go in the workstream menu. Workstream menu is over here also. There are two tree menus given so that you can work at one side in the command, and on the other side you can use the workstream menu. So I'll just select the exterior columns. Okay. And for the X direction, these will be interior columns. So I'll inactivate these. Let us make it in the wind load in X direction. We need to just take care that the load case name is also taken into account. If otherwise, we can just click over here and see in the table format what all loads we have given and change it anytime, at any point of time. Okay, so let us provide some in global X direction. So let's keep it as 9.8 kilonewton per meter. These are all calculated values and you can find it in the tutorials. Of course, when for wind calculations, manual calculations have to be done, and such kind of element loads or nodal loads are required to be applied. In case of RCC structures, we have got wind loads as a command, but in case of structures like steel structures, roof trusses and all, we have to manually calculate and apply as element loads and nodal loads. So now that we have applied it for the exterior columns, let us activate all interior columns. Activate. This will be in the 4.9, let's say. Apply. Select and apply. Okay. Yeah. Even these. Now we'll activate all. And open the exterior columns, activate. Now for the Y direction wind load, select the load case, change the direction to global Y, and the outer ones will be having 5.5 kilonewton per meter. For Y direction, these are the outer columns. So apply, and for the interior columns, the value is 2.7 kilonewton per meter. Similarly, I'll just activate the interior columns. Select them and apply. Okay, so now we are done with applying the loads. Now the next point is the analysis, performing analysis. So let's go to the next menu tab and perform the analysis. Yeah, there are certain warnings that talk about the trusses, so they can be ignored. Let us go ahead with the results. In results, we can do auto load combination. So let's go to load combinations and let's go to the steel design tab and say auto generate. So steel is there, and IS 800 2007 is available, even 1984 is also available. So let's say OK. So according to the strength and serviceability, both load combinations are created. Okay, so next we can see the results now. Let's see the reactions. So over here, let's take one of the load combinations and apply. So you can see over here, even you can see the values. Let's take it as FZ only. Yeah, so you can see that 704 and this value is the highest one. So it is turned into red. Okay, going ahead, we'll see now with the deformations. Displacement contour. So you can see the values, deformed shape, the animation. So in this way, your animation can be seen. Okay, then we'll go ahead for the beam diagrams. So for the floors, let's take the MY and say apply. Let's see the solid fill, and it's deformed. So let's just go back to this and then go to the beam diagrams and forces, the solid fill, and apply. Let's take for this load combination, not only for self weight. So as you can see over here, your bending moment diagrams, you can see it with the values by just selecting certain and activating them. Or what you can do is do the quick view, in which you can select any element and any load case can be checked there and there itself, and for any component. SFD, BMD, port diagrams, you can see them. So this is about the quick view of the beam diagrams. Now let us go ahead with the design. Let's get back to the initial view. Design. Now in design we have got steel design using IS 800 2007 and also 1984. So in steel design, firstly you do design code. Over here now all beams and girders, they are laterally braced, so let's check it on. And next part, you can change the partial safety factors. Right now they are according to the code. Change the code and then you can update it. Any steel material you want to modify, you can check over here the tensile strength and the yield strength, everything. You can change it over here. Then the equivalent moment factors you can apply. Now let's directly go ahead how the design is done. Obviously in steel structures, the members are already assigned by us, but I mean the section properties are assigned by us, and all we need to do is code checking. So steel code checking will be done. The solver speed of MIDAS is pretty good. As you can see, it is going to be performing the analysis within seconds. The design within seconds, yeah. Okay, so now over here we see the result dialog box. So we can see by properties, we can see by members. Many of the members are red, many of the members are blue. So the difference is that this is not good, red is not good, and blue is okay. The not good star is it is almost almost failing, and okay star will be it is almost passing. Okay, so let us see a quick summary by using graphics. So why it is failing? It is failing for the actuals. Let's check in detail. So in detail you can see all the parameters that have been used, and like which codes, which clauses have been used, the tables, everything is available. You get a detailed report. The slenderness ratios, actual compressive strength, actual strength, it's failing. So by 0.1, by 0.128, so it is not acceptable, that's why it is failing. So now we can save this file. So let us see how we can do the optimization. So I have now selected that certain element. I have to just go and change it. Now here we are. This is a kind of optimization only. This is it's a failed beam. So even if it's a passed beam, you can change it and search satisfied section. So it will show you all the section properties coming under IS 1161 and I section. You can change the section also and search satisfied section. So that also can be possibly done. That is also possible. Also, you can restrict its height, its width, its thickness, everything you can, it is under your control. The software will not do only by itself until you say, you select and you say change. It will again check and say close. So here again I'll show again how it happens. I select, I say change and say close. So it has turned into blue because we have changed the section property. Now similarly we can do the steel optimization by using the steel optimal design. So it is again going to check all the members. Okay, so as you can see over here, certain members are failing like the floor girder, the roof bracing, wind braces. So what we can do, we can just select them. Okay, and over here there are design criteria. Again, restricting of any of the heights or a restriction of any dimension is possible over here. If you do not want to restrict, then 0. 0 means it will select from the database. If you have different sections, then you can say user defined section and provide the properties. Okay, then there is analysis option in which it does some iterations and repetitions. So let's take it as 2. Okay, and say design and analysis. So now it is checking for the first time. And now for the second time. Okay, so we can see over here that it is not able to find any proper section. So we'll see in the result text report that what optimization was done for the first time and what was checked for the second time. And we can give more number of repetitions for it to come to a proper conclusion. And then, like using the model update, the entire sections will be changed if required. Right now it was not passing, so I'm not changing the model or updating the model. So in this way you can complete your modeling, loading, analysis and design and do the optimization of your steel structure. Okay, I'll also show report generation, or let's say bill of material, these tools, certain tools that are required. Section property calculator is there for creating any other shape section. Then MIDAS GSD is there. This is an additional option, which is general section design, where you can design also. Then bill of materials. So you can obtain bill of materials And now we have got data generator, or let's make a dynamic report generator. Now this directly takes you to Microsoft Word. Okay, so we're directly into Microsoft Word, where we can type in the project name and the requirements. Okay, so now this is our structure. I'll right click and say dynamic report image. Okay. If you go over here in this tree menu, report, so this image is there. Just drag and drop. Okay, so now our image is over here. Then certain results also are required. Say result tables are required. I want these load combination. These are some results. Again, right click and say dynamic report table. I can also select which load or which cases are required, or rather components are required. I'll go to the report editor, close this. So reactions tables, just drag and drop. So my reactions are also there. Now the best part about this dynamic report generator is if you make any changes in this model, like go in the post-processing mode. Okay, these are certain buttons, direct buttons over here. So go in the post-processing mode, pre-processing mode, change any of your element. Let's say I'm deleting certain part. Just select and delete. Okay, I reanalyze it. And then I go to the report editor. I go to the tools and say auto regenerate. I say select all the charts, text, image, files, everything, and I say regenerate. So as you can see over here, the reactions have changed and even the model has changed. So in this way, at any point of time, you can keep making changes and the reports will automatically get generated. Okay, so in this way, you can get your reports, your result reports in the table format. You can get the result reports in chart format. Let's like select some, show graph. So there are n number of ways you can actually view your, yeah, there are a number of ways actually you can view your reactions, or rather the results, and you can create a detailed report on that. So this was all about our steel structure. If you have any queries, you can write us at techsupport@midasit.com. We will be sending you mails. Also, this video will be sent to you. So if you have any queries, just write to us, and also give us a good, or rather a feedback on how our webinar was and the ways we can improve it, and any more type of webinars you require. Okay, thank you for attending our webinar. I'm ending the session now.